In order to cover factoring, we need to review the FOIL method. FOIL is an acronym that stands for first, outside, inside, last. FOIL is used when we have a binomial times a binomial. Binomial means two terms. So when we have a two-termed polynomial times a two-termed polynomial, we're going to use the FOIL method. Now, FOILing is really just the distributive property. If you think about it this way, I need to take this first term, this x, and multiply everything in this binomial by x. So I need to take x times x and x times 2x. So I'm really taking first terms times outside terms. And then I need to distribute this second term into everything into this binomial. So I need to take 3 times x and 3 times 2. So I'm really taking the inside two terms times the last two terms. First, outside, inside, last. FOIL just helps me remember how to use the distributive property correctly. After I've distributed everything, I need to collect like terms. I have 2x plus 3x, which gives me a grand total of 5x. Factoring is the opposite of FOILing. Factoring and FOILing are inverse operations. Kind of like multiplication and division are inverse operations, factoring and FOILing are inverse. So if I start out with this polynomial, we have a trinomial. The reason it's a trinomial is we have 1, 2, 3 terms. So if I need to factor this trinomial, I need to rewrite this trinomial as the product of two binomials. Now in this case, I have a leading coefficient of 1. What does that mean? Well, if I look at my first coefficient, it's the leading coefficient. The value out here is 1. I have 1x squared. So if I'm going to undo the FOIL method, that's where I want to start. My first two terms have to multiply together to give me x squared. And my last two terms have to multiply together to give me my last number. In this case, 12. So what two numbers multiply together to give me 12? Well, let's try 4 and 3. Now this is a positive 12. I can get a positive 12 by either multiplying a positive 4 and a positive 3, or a negative 4 and a negative 3. In this case, since my second term is negative, I want both of these numbers to be negative. That way, when I FOIL, this middle term will be negative. So let's FOIL this to see if I have the correct factorization. First times first, outside times outside, inside times inside, and last times last. Negative 4 times negative 3 gives me positive 12. Collect my like terms. I end up with a middle term of negative 7, but I wanted negative 8. So this is not the correct factorization. I need to try something else. "12" can be factored into 4 times 3. It can also be factored into 2 times 8. So my first two terms have to multiply together to give me x squared, x and x. And my last two have to multiply together to give me 12. 2 and 6. And again, I have a positive 12, so both of these have to either both be positive or both be negative. I still want them both to be negative because that will give me a middle term that is negative. So let's FOIL this out to see if I'm correct. First times first, outside times outside, inside times inside, and last times last. A negative times a negative is a positive 12. Collect my like terms. And here I go. X minus 2, x minus 6 is the correct factorization of this trinomial. Now let's look at a trinomial where the leading coefficient is not 1. In this case, the leading coefficient is 8. Again, I want to factor, so I'm going to factor this into a binomial times a binomial. And my first two terms have to multiply together to give me 8x squared. So I need to look at what's going to multiply together to give me 8. I'm going to pick 4 and 2. And x squared. So 4x and 2x. And now I need to look at what two things are going to multiply together to give me 5. Well, 5 is prime, so the only thing that multiplies together to give me 5 is 1 and 5. But I need this to be a negative 5. To get a negative, I can either multiply a positive times a negative or a negative times a positive. I'm just going to try positive 1, negative 5. Let's check this answer. First times first is 8x squared. Outside times outside is negative 20x. Inside times inside. Last times last. Combine my like terms. I have 8x squared minus 18x minus 5. Well, that's not what I wanted, so I'm going to have to try something else. I'm going to have a binomial times a binomial. Let's try 4x again and 2x. And this time, I'm going to switch around the 1 and the 5. Now it doesn't look like I changed much, but now when I FOIL, I'm still going to have 8x squared, first times first, but now my my outside is going to be 4x times negative 1, which gives me negative 4x. And my inside is going to be 5 times 2x, which is 10x. And my last, negative 5. Combine my like terms, I'm going to end up with 8x squared plus 6x minus 5, which is really, really close to what I wanted, but not quite there. So I'm going to try one more time. I'm going to have a 4x here and a 2x here. And I want the 4 to be paired with the 1. And I want the 5 to be paired with the 2. But this time, I want the 4x to be positive. And I want the 10x to be negative. So by doing that little change, I'm going to get a completely different result. 4x times 2x is still 8x squared. Outside, this time I get positive 4x. Inside, I get negative 10x. And last, I get negative 5. Combine my like terms. 8x squared. 4x minus 10x gives me negative 6x minus 5. So here is my factored answer. Now for these two problems, I used a guess and check method. I didn't always get the correct answer on my first attempt, but then I just tried again. until I got the right answer. I promise you, the more you practice these, the less time it will take you. Once you do enough of these, you're going to just start to see the patterns with the pluses and negative signs, and you're going to start to see what numbers multiply together to give me the correct answer. It just takes practice. Let's look at two more problems that involve factoring special patterns. Here I have a trinomial, and I need to factor that into a binomial times a binomial. So I need to look at what numbers multiply together to give me 9x squared. And it's 3x and 3x. And what two numbers multiply together to give me 4? 2 and 2. And in this case, this 4 is positive, and this 12 is negative. Or excuse me, positive. So there's two ways to get this positive 4. Positive 2 and positive 2, or negative 2 and negative 2. In this case, since this 12 is positive, I want both of these 2's to also be positive. Slightly different than this problem where I needed a negative and a negative to make this positive, so this would be negative. I need a positive and a positive, so this will be positive. Let's check our answer by foiling. 3x times 3x is 9x squared. Outside, 3x times 2 is 6x. 2 times 3x is 6x. And 2 times 2 is 4. Combine my like terms. Yes, this does work out. So how is this a special pattern? Well, if you look, both of my binomials are the same. Since both of these binomials are the same, I can rewrite this as 3x plus 2 squared. So I have to, when my binomial is exactly the same, rewrite it as that binomial squared. This is another reminder that 3x plus 2 squared does not equal 9x squared plus 4. I can't just distribute over a plus sign. I can't distribute an exponent over a plus sign. This is not true. This actually equals this, which gives me this trinomial. Last special pattern problem. In this case, I have a binomial. So I still need to factor this binomial. The piece that's missing is my x term. I have an x squared term, and I have a constant. What I don't have is an x term. So it's kind of like I have my first and my last, but not my O and my I. I'm still going to factor it into a binomial times a binomial. My first two numbers have to multiply together to give me 49x squared. So it's going to be 7x and 7x. And my last two have to multiply together to give me 100, which is going to be 10 and 10. And I need a negative 100. To get a negative number, it's either a positive times a negative or a negative times a positive. Let's FOIL to check this answer. 7x times 7x is 49x squared. Outside, 7x times 10 is positive 70x. Inside is negative 70x. And last is a negative times a positive, which is a negative, and 10 times 10 is 100. Now watch what happens when I combine like terms. I have 49x squared plus 70x minus 70x. These two terms disappear, and I'm left with just minus 100. So my factored answer is 7x minus 10, 7x plus 10. Notice that these two aren't exactly the same. They're close, but they're not exactly the same, so I don't want to write it like I did this first example. This is my final answer. This pattern is called the difference of two cubes. The reason that this is the difference of two cubes is 49x squared is a perfect square, and 100, excuse me, this should be the difference of two squares. I'm getting a chapter ahead of myself. 49x squared is a perfect square, and 100 is a perfect square. So when I have the difference of two squares, I can factor. If this problem was 49x squared plus 100, I would have the sum of two squares. And when I try to factor this problem, I end up with 7x and 7x, and 10 and 10. And now to get this positive 100, this either has to be positive 10 and positive 10, or negative 10 and negative 10. And either way, I end up with a middle term. Even if I made these both minus minus, then this turns into minus minus, and this turns into minus 140x. The reason that this works is because I have a minus sign here. I'm subtracting, which means that I have one positive and one negative, which allows me to cancel out. This, the sum of two squares, cannot be factored.